Hey everybody, it's Miss Howell. Okay, this is a rough one. It's actually easy and fun for me to teach, and I really enjoy this lesson, but I talk too much. This is the third time I've tried to record this for you. So I'm going to go faster, and I apologize. All right, so this is the circulatory system. We're going to talk about blood today. Look for the red words, fill in your guided notes, hit pause when you need to get things filled out. You're also going to have some vocabulary words along the way to fill in. The circulatory system includes not only the heart and the various blood vessels, but it also includes the blood that has to travel through the structures. So this week's lesson, we're going to focus on the blood. Next week, we're going to talk about how blood is carried through the body, through those vessels, and using the heart pump to do the work. So what is the work of blood? Well, the work or the function has three parts. Blood is, first of all, a transport medium. That just means it's moving oxygen and carbon dioxide between your lungs and your tissues. It's moving nutrients and waste. And last week we learned that it moves hormones from the starter organ where the hormones are made to the location they're used later in the body. As a transport medium, it's really speedy. Your heart pumps every bit of blood in your body through a complete circuit every minute of every day. And if you're doing some strenuous exercise and your heart has to pump really hard and fast, it actually can move the blood through your body even more quickly than in a minute. It may even take half a minute for all your blood to pump through your body. As a connective tissue, which we'll talk more about in a minute, how the blood is a connective tissue, blood is a regulatory tissue. So it regulates your amount of fluid volume, it equalizes temperature throughout your body, and it regulates pH within your tissues. It's also an excellent protective tissue. Certain blood components work to clot the blood in event of a cut to protect you against fluid loss. There are other components within your blood that fight infection, and that protects you from illness. So now let's move on to some physical properties of blood. First, we need to do a couple of definitions. One is viscosity, the resistance of flow and alteration of shape due to cohesion. That basically just means thickness, how much thicker something is than water. So blood has a higher viscosity than water. It's 5 times thicker than water. Another term we need to define is density. Density is mass per unit volume. You probably learned that in physical science. Well, an easy way to think of that is also the compactness. Things that sink in water would be those things of a higher density. Blood is slightly more dense than water because it contains iron. If you happen to have low iron, iron poor blood or anemia, then your blood might be a little less dense than normal, but still your blood is a little bit more dense than water. Also, the pH of blood is very tightly controlled with a level of between 7.35 and 7.45. Therefore, your blood is very slightly alkaline. And also of note is the average adult has 5 liters of blood in his or her body. You may have heard that before. So every time your heart pumps, for 1 minute, all 5 liters of blood are pumped throughout your body. So what is blood actually made of? Well, blood is made of 2 components, and we're going to break them down a little bit. But first, just know you're made of plasma. Your blood is made of plasma, which is the fluid portion. That's 55% of your blood. And then you've got formed components. Those are the cells and cell parts. There's 45% of that, and we're going to look at a little sample of that in class. So we're going to break each one of these down in more detail to help them make a little more sense to you. So plasma, let's start with that first. So plasma, 55% of your blood, well, 91% of that is just water. Also of note, plasma is not even red. It's pale yellow in color. So when you spin down blood in a centrifuge, it separates the blood plasma on top and the packed units on the bottom, while the plasma on the top would be pale yellow in color. So 9% of your plasma, the stuff packed down in the bottom, would contain your proteins, gases, nutrients, ions, waste. And in that you've got albumin, globulins, and fibrinogen. Albumin helps to regulate water in your tissues and blood. Globulins are carrier proteins and your immune cells like hemoglobin and immunoglobulin. And fibrinogen is a component that assists in your blood clotting, and we'll talk about that in a bit. All right, also in your blood now we have our formed elements. So the top half in that diagram had been your plasma, the 45%, I'm lying. 55% was plasma, 45% is your formed elements. In that, 99% of that are your red blood cells, also called erythrocytes. Erythrocytes, or RBCs. And their only job is to transport oxygen and carbon dioxide. They're just carrying your oxygen to your cells and carrying waste carbon dioxide out of your cells. Leukocytes are the white blood cells. Those are your fighter cells. And then you've got platelets, which aren't even full cells at all. These are clotting cell fragments, and they're there to help prevent blood loss. So let's zoom in and look at the erythrocytes. So the erythrocytes are biconcave discs. That means they're pinched in on both sides and they're little circular cells. That pinched in center helps it to be more flexible, and it also increases the surface area so it can carry more oxygen. They're made of hemoglobin, which is a protein folded molecule combined with heme and iron. The iron is responsible for blood's red color, and yes, blood is red all the time. It never turns blue in your body like some people think. And iron is what binds to oxygen and helps to carry the oxygen and transport it around your body. Another neat fact about erythrocytes is they are anucleate. That means there's no nucleus. Well, that's weird, right? How do you have cells that don't have a nucleus? Well, these cells don't need a nucleus because they're not going to live long. They only live about 3 months. They don't need to carry out cellular respiration because they're not doing a whole lot of functioning. They're just a kind of a carrier truck, and they're carrying oxygen around. So there's no DNA. They don't multiply through mitosis, and so they don't need a nucleus. I think that's really cool. All right, now let's talk about leukocytes. Leukocytes are your white blood cells, and there's many fewer of them than there are red blood cells. Your red to white cells are a ratio of about 700 to 1. Leukocytes don't just stay inside the blood vessels, they actually can get out, and they move by an amoeboid movement. They can stretch out an arm and pull themselves forward and have this movement that is directional, like they can know where to go and they can slide their bodies forward with this amoeboid movement. And this moving out of the blood vessel is called diapedesis. It's passage of the formed blood elements through the blood vessel wall out into the tissues, diapedesis. And how do they know where to go? They don't just go willy-nilly anywhere they want. Well, it's because of chemotaxis. So infection or invaders in the body or dust particles in your sinuses or whatever set off a chemical alarm that is attractive to certain white blood cells, and they exit the blood vessel via diapedesis and move in direction of the chemical that's attracting them. Different types of white blood cells. So the red blood cells are just one kind, but we have 5 different kinds of white blood cells. Some of them are granulocytes, which just means within the cytoplasm there's these granular structures. There are 3 types of those. So we'll start with neutrophils, which is the most common white blood cell, and they fight infection by phagocytosis. They're cell eaters. So when you get sick or when you get an infected wound, neutrophils go and they eat up the bacteria, which is kind of gross, but I'm glad they do it. We also have eosinophils. Eosinophils got their name because of the fact that they turn red when you stain them with the red stain, and eosin is the word for red. They're going to reduce inflammation. Now that balances out basophils, which we're going to get to next. So remember, eosinophils reduce inflammation, and then the third granulocyte, which is basophils, they increase or promote inflammation. So they got their name because they're attracted to a blue dye instead of a red dye, and the blue is basic or alkaline, and basic, basophil, get it? Got the name? Okay. They're very granular, and they release histamine during an allergic reaction. So if you've ever gotten hives, that red splotchy area all over your body, that's a histamine that's been released because of an allergic reaction, and it's the basophils that are to blame. They're promoting inflammation, but that is necessary because that stimulates immunity and helps you fight the inflammation or the irritant that's bothering you. They also are good at releasing heparin during infection, and heparin is a thinner. It thins blood, and that limits blood clotting temporarily so that blood can get to the infected area and bring faster the blood cells that you need. All right, let's move on to the agranulocytes. These are called agranulocytes because within these white blood cells, the cytoplasm does not have any granules that are kind of obscuring your view. So the first one is lymphocytes. They're the second most common white blood cell that you have, and they produce antibodies. When you look at a picture or a diagram of cells, blood cells, usually when they point out something and just say, generically, that's a white blood cell, it's usually a lymphocyte that they're pointing at. They produce antibodies to fight foreign invaders. And then another agranulocyte is a monocyte, which is really uncommon unless you've got mononucleosis. So it's the largest of all of your blood cells, and it will destroy invaders and dust and bacteria by phagocytosis. They're cell eaters. And they are made in really large numbers if you have mononucleosis, which is how they got their name for monocytes. These cells can also leave the bloodstream and move into your tissues through diapedesis, and when they do, their name is called macrophage. They get kind of changed to a new name. I don't know why they don't call them monocytes then, but they don't. They call them macrophages, and that just is a big fancy word for big eaters. You macrophage. Say that to your friend next time they hog all the pizza. All right, hemopoiesis is how blood is made. So define that on your paper, write it out on your guided notes. Hemopoiesis is the process by which blood is made. And all the blood cells, whether they're monocytes, neutrophils, eosinophils, erythrocytes, all of them are made from bone marrow. And they all come from the same type of starting cell, which is called a stem cell. And I forgot to make that red. So number 31 on your notes is stem cell. Now we move on to how blood works as a connective tissue. So remember, blood is a connective tissue. We learned about that way back in the second module of the book. It's made of cells, check, and connective tissues have to contain fibers, check. We can best explain that if we look at the role in hemostasis, another vocabulary word. Hemostasis is the process by which the body stops blood loss. Basically, hemostasis is how the body clots its blood. Well, there's 3 steps to that. The first thing that happens is the vasoconstrictive stage, and that's just the blood vessel itself constricts or closes off as a response to injury. That kind of shuts down the flow of blood to the area slightly. And then the second part is a platelet plug stage. So this is where those platelet fragments kind of get gathered together to form a plug, and that happens because the cut itself has exposed the blood that's leaking out to collagen, which surrounds the blood vessel. So when collagen comes in contact with blood, that starts that chemotaxis, which recruits or lures platelets to the area, and it also causes the platelets to become sticky. So they'll kind of glob together to form a platelet plug to plug up the hole. And then last is coagulation. Coagulation is a clotting process that has a huge number of complicated steps. They're in your book. You can read them if you'd like. It's called the clotting cascade. It involves certain vitamins and a certain order of things happening. Your liver is involved. I'm not going to test you on that, but if you're interested in it, feel free to go back and read that in your book. Blood types. Humans have 4 basic blood types. You may know this, and I don't know if you know your own blood type or not, but everybody is either A, type B, type AB, which is a combination, or type O. And each of those 4 can be either positive or negative. I know that I'm O positive, and we're going to find out what your blood type is. Blood types are determined by surface antigens on individual red blood cells. And we're going to talk about this in class a little bit. Genetics is what determines your blood type. You've inherited whatever your blood type is from your parents. And if you remember Punnett squares, we'll look at that a little bit in class. So antigen, the surface antigens on the blood cells, are just proteins or carbs that trigger production of antibodies. Because we have these antigens on our cells, our blood cells, and what they do is they trigger this immune response, it would be deadly to give someone the wrong type of blood in a blood transfusion. That's why it's super important for you to have your blood type known before you receive a blood transfusion. And I've ordered blood type kits. Hopefully they'll get here in time. I've ordered them through Amazon. They should be here in a couple of days. If they get here, we're going to use them in class, and we're going to figure out each one of our blood types. All right, so that's all for today. We're going to stop here, and then next week we're going to talk about the organs and the transport of blood and how it moves through the body. Thanks for listening.